Hey guys, today we're going to talk about how to find the domain and range of functions. We're going to start off looking at the vocabulary for what is a domain, what is a range, and then we're going to look at finding the domain and range from graphs. Because that's mainly what you'll do in our course, but it's very important to understand the idea behind domain and range because really they encapsulate everything about this class, okay? So domain, it is the set of all possible x values, okay? And range is the set of all possible y values. Okay, so first off, that is necessary information. I would write that down. But what I also want to talk about is this idea that domain is also, it is a set of all possible x values. So what are x values? Well, they're inputs, right? So that means domain is any number I could possibly input into a function. So I input a domain in, and then the range is the set of all possible y values. What else do we know y values are called? Output values. So then we know that the range is really the set of all possible output values. Now, which one causes the other? Which one causes the other? That's right, input values cause output values. So we input something into some function, okay? We input something into some function and it goes beep, 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 beep. And the function reads it and we do that calculation and then the function spits out an output, okay? So the domain is an input into a function and a range is an output from a function. Okay, so a very, very quick non-graph example, such as let's say we have the function y equals 2x plus 3. Okay? Well, what are some possible domain values? Now you'll notice I didn't say all possible domain values, so I'm not giving you the entire domain. I'm just saying what are some possible domain values? Well, what about the number 0? Think about this for a second. Can you plug 0 into 2x plus 3? And when I ask that, can you plug 0 in, I mean, is it going to cause an error if you plug 0 in for x? Is it going to cause an error somewhere? No, because you can plug in a 0. You just simply get 2 times 0 plus 3. And what do we know 2 times 0 is? 0. And we know 0 plus 3 is 3. So then we know that one possible domain value is 0 and one possible range value is 3. So this is an input and this is an output, but is this the list of all possible inputs? And is this a list of all possible outputs? No, it's not. We simply don't have them all written down. Okay? So let's talk about how can I find all possible input and all possible output? Well, one of the easiest ways to find the entire domain, which is all possible x values, and the entire range, which is all possible y values, is to see a graph of the function. So, maybe you don't know how to graph y equals 2x plus 3, but since it's x, just being raised to the first power, just this guy right here is just x understood to the first, okay? That means it's linear, so that means we have a line. So I go up 3, because that's my b value, and 2 is my slope, so that means I go right 2, and then up another 1. So it means I have something like this, and something like this. It also means that if I want to, I could go down 2, left 1. So I could also be right here. So this is kind of what my line looks like. Sorry, I'm not very good at drawing, but this is what my line looks like. So you look at this line, think about it, just think about it. What are all the possible x values? Remember, lines continue on forever, infinitely in both directions. Hopefully you're like, well, it would be all x values, right? Because if the line continues to grow to the left, which we know lines do, and the line continues to grow to the right, which we know lines do, will we eventually hit all possible x values on either side? Yes, think about it. Would eventually, somewhere on this line that I just drew, the value of negative 100 for x happen? Yeah, it would happen somewhere over here, and we'd be somewhere right here on the graph. So it would happen somewhere right here. What about an x value of 10? Well, that's probably somewhere more right here. And I would fall right there on the graph. So you see how every possible x value will fall somewhere on this purple line? That means that I have all the possible x values. That means every x value is included. And I'm going to show you actually how to write that down formally in a second. But I just want you to kind of think through, like, do you see how every x value from left to right is going to be included on this line? Now what about the range? What do y'all think the range is? That's right, it's the same idea because range is y values, all possible y values. And since a line goes up and down forever, I will eventually hit every single y value will be somewhere on this purple line. Alright, so let's talk about this a little bit more formally. I was trying to hope that that would kind of get your brain moving in the right direction, but let's talk about this a little bit more formally. Alright, so here we have our domain and range worksheet, which is going to be handed out in class for you. And you'll notice that we have 3 different ways that we are actually going to write down the domain. Alright, so a second ago we just kind of talked about the domain look like. We didn't get a real fixed formal method for writing down the domain. Now we have 3 different ways that we're going to write down the domain. We have inequality format. We have set notation, which is really just inequality format, just a little bit fancier. And then we have interval notation. Okay, and I give you guys some hints. Don't use infinity symbol. Set notation, don't use infinity symbol. But in interval notation, you will use infinity symbols if it calls for it. Okay, so first, let's look at the graph right here. Alright, now this one's a little tricky. It actually starts out kind of hard. But look at this. I know it looks like a line, but look very, very carefully. Is this line actually going on forever, left and right? Hopefully you're like, well, no, it starts right here. It doesn't keep going to the left or down, does it? This is it's kind of like your starting place, and it just shoots off up and to the right after that. So that means that the lowest x value, so right now we're just going to talk about domain, all right? So that means that when we're thinking about domain, y values don't matter, okay? All we care about now is looking at the graph from left to right. We now completely ignore up and down when we're talking about domain, okay? When we're thinking about domain, all we think about is x values. We ignore the y values, okay? So when we're looking at this line, you write domain, you have to find the most left value, and then you have to find the most right value, okay? So in other words, you have to find the least x value, and you have to find the greatest x value, okay? So when you're looking at this line, what is the least x value that this line has? Is it 2? Is that the smallest x value that this line has? Hopefully you're like, well, no. The least x value it has is -1. Okay, and what do I do after -1? Well, I just continue to go to the right. Again, we're talking about domain, so all we care about is left and right, not up and down right now. So -1 is the least x value. It's the most left x value I have, and then I just go to the right after that. And then what is this right here? Well, that's an arrow. So that means I'm going to continue going to the right forever. So, before we write stuff down, just write a little note. You don't always have to do this. I'm just suggesting for the first problem that your most left x value is -1. And your most right x value is an arrow. Okay? Alright. So, the way we write that in inequality format, the way we're going to write this answer in inequality format is, first off, what are inequalities? Well, there's these symbols, right? Less than, greater than, less than or equal to, greater than or equal to. Alright? So, what you do is look at this graph. How could you potentially write the domain for this graph from these inequalities? Well, first off, domain is all possible x values, right? So if you're writing in inequality format, you're always going to write x. Okay? So again, if you're writing in inequality format and you're writing the domain, you will always have to include an x. And then what am I doing after this -1? Well, the x is getting bigger, right? It's going to the right. It's growing. So x is greater than, so I'm going to say x is greater than, what was the most left x value? -1. So the domain is x is greater than -1. Think about that for a second. Do all my x values, can I make this statement that all my x values are greater than -1? Well, look at this line. Is that a true statement? Are all my x values greater than -1? Well, yeah, because after I started here at -1, I just went to the right. I never went to the left, so I never got smaller. I only got greater. Now, the reason we use greater than and not greater than or equal to is, do y'all see how this is an open circle? That means I cannot include that x value. So that's why it's just x is greater than -1 and not x is greater than or equal to -1. Alright, so now let's talk about our range. our range is a very similar idea, but instead of dealing with x values, we're going to deal with y values. So instead of going left to right, because that's how domain is read, left to right, that's how x values are read, left to right, range is read bottom to top. So you want to look for your lowest y value again, your smallest y value, and then you want to look for your highest y value. Well, looking at this line again, oh, I cut the line in half there. Looking at this line again, what appears to be your lowest or your most bottom y value? Well, hopefully you're like, oh, well, 1. This line, the lowest y value is 1. Okay, so that's my lowest. And then what's my greatest? Well, we have a y value of 1, and then what does it seem like we're doing after that? We hit that arrow. So we're just going up and up and up. So hopefully you're like, oh, this is easy. Y is greater than 1. Okay? So that's inequality format. So now we need to write this same answer. Okay, we're not changing our answer. We need to write this same answer simply in set notation. Okay? So, again, it's very important to realize that we are not actually changing our answer. We are just simply writing in set notation. Set notation is just a fancy way of writing inequality notation. So if it's domain in set notation, all you're going to do is draw yourself a curly bracket. So since this is domain, we use the variable x. You're going to write an x, and you're going to write a straight line. Okay? And then you're just going to write x is greater than -1. Because that's what the inequality format was. So set notation is simply the inequality notation including x and a straight line. So then the range is the exact same way. So you curly bracket, but we're dealing with y now because that's range. So we say y, straight line. And then what was the inequality format for this graph? That's right, it was y is greater than 1. Alright, and then we close it with another curly bracket. Alright, that's all set notation is. Alright, it's just simply the inequality notation including the variable and the straight line. Now, interval notation is a little bit different. Interval notation is you ask yourself, let me say this. Interval notation deals with, you use, instead of using greater than, less than signs, you use brackets and parentheses. So you could have a bracket bracket, you could have a bracket parenthesis, you could have a parenthesis bracket, or you could have a parenthesis parenthesis. So what do these mean? Well, bracket means the numbers are included. Parentheses means the numbers are not included. Okay, such as we had that open circle, right, at -1 for the x value. So that means that it would get a parentheses. Here's always how you do interval notation. Least, greatest. And then you surround it with brackets or parentheses based on what it needs. Okay? So in other words, for my domain, what was my least x value? What was the smallest x value? What was the most left x value? That's right, -1. Now, here's where it gets a little tricky for students. What was my most right x value? Now, you can't see it on my page right now because I can't see the graph. But go back, look at what was the most right x value. Hopefully you're like, oh, it was that arrow. Well, what does the arrow represent? Infinity. Very good. It means I keep going on forever. So we call that infinity. So then my greatest x value is infinity. So we draw our infinity symbol. And then -1, that comes from an open circle. I'm sorry. Yeah, an open circle, so it gets a parentheses. And infinity. Can you ever actually reach infinity? No. So infinity will always get a parentheses right next to it. Alright, so now let's talk about our range. Same idea, least to greatest. It's just instead of x values, we're doing y values. So what was your least y value on this problem? Well, hopefully you're aware that it was 1. So you're like, oh, it was 1. What was your highest y value? Well, that's right, it was infinity again. And so, parenthesis, parenthesis. Alright? Alright, let's continue on. Okay, so let's go on to number 2. I highly encourage you to pause the video and try to do this guy on your own right now. Okay? But it might throw you for a loop, and that's okay. So hopefully you've just paused the video and you're coming back and you're kind of like, oh, I got it, or I'm still struggling. Okay? So let's start off with domain. Remember, domain is a set of all possible x values from left to right. So when I look at this graph, what is the most left x value happening? An arrow. When I look at the right part of the most right part of this graph, what is the most right happening? An arrow. So wait, that means technically I'm going to continue expanding forever left and right. So then what is the domain? Well, it's all possible x values. We hit every x value. So how do I write that in inequality format? You can, in inequality format, you can literally type all real numbers. Okay, my text is a little big, but all real numbers. That is the domain. Since you get all x values, we technically hit every single number, so all real numbers. All right, so let's go to range. When you're looking here, what is the lowest y value you see happening on this guy right here? What is the most bottom y value, the lowest y value, because we're talking about range now? Hopefully you're like, well, that's happening right there instead of y value of 2. Okay, so then you can say that y is something with 2. What does y do after 2? Does y get greater than 2 or does y get less than 2? Hopefully you're like, oh, y is greater than 2. And you might be tempted to leave it like that, and I would understand why you're tempted. But is this an open circle or closed circle? Well, since you can't see an open circle, we get to assume it is closed. So we say y is greater than or equal to 2. Alright? Okay, so let's go to set notation now. Set notation, remember, is just simply inequality notation with brackets drawn. So bracket, x, straight line, and then what did I write? Well, I wrote all real numbers. Now, I'm going to show you a symbol that you can write instead of all real numbers. You can write what's called a funky R. Okay? And that R just simply means all real numbers. Okay? So then the range would be bracket, y, straight line, y is greater than or equal to 2, because that's what the inequality format was. Alright, so moving on. Let's go on to this set notation. Sorry, not set notation. Interval notation, my apologies. Interval notation. Okay, what was your most least x value? What was your most left x value? What was the smallest x value you had? Well, right now you're probably thinking, well, I don't know. I had all possible x values. Okay, so then that means that I got to go, so this is kind of what the graph looked like. So that means this arrow over here means I'm going to get to go to the left forever. So that means if I'm going to the left side of x, hopefully you realize that's going to make x values smaller, making them negative. So we say that that's negative infinity. And since it's an infinity sign, I put it with a parentheses next to it, comma, and then I'm going to the right forever, so that would be another infinity sign. And there you go, that's the domain. So then the range for this guy, well, what was your lowest y value? That's correct, it was 2. What was your highest y value? Well, it was arrows pointing upwards, so that means I'm going to go up forever, so that means infinity. So I can say bracket, because 2 was included, it did not come from an open circle, so it was included, so bracket 2 to infinity with a parentheses. And there we go. Okay? Alright, let's try to do the next one here. Alright, so I really do encourage you on this one to pause and try to knock this one out completely on your own without any help. So hopefully you've just unpaused your video and now you're feeling good and you're like, the domain in inequality notation. Well, I know that domain is all possible x values from left to right. So here's my graph. It's this line, and I notice there's an arrow pointing to the left and an arrow pointing to the right. So that means that my domain, I'm going to hit every single x value because I go to the left and right forever. So I'm going to hit every possible x value if I go to the left and right forever. So my domain is all real numbers. I'm going to draw that funky R. Okay? So what's my range? Well, once again, look here at your range. This arrow is pointing down. This arrow is pointing up. So wait, is there going to be a single y value you miss? No, you're going to hit every single y value. So then the range is the exact same thing. It's all real numbers. And then you're flying over to set notation because you're like, I got this. Set notation, you draw the curly bracket, you put the appropriate variable, since it's domain, that's an x. You draw a straight line, and you just put whatever you put for inequality, which is the funky R. You draw yourself your bracket. Same thing with range. You draw yourself a bracket, you put y, you draw a straight line, and then you put a funky R. And then you draw yourself a bracket. And now you're ready to go on to interval notation, which interval notation, simply, if it's going to be all real numbers, that just simply means negative infinity to positive infinity. Negative infinity to positive infinity. And there we go. Okay? Last but not least, and this one is a tricky one. Okay? Alright. So first off, when we're looking at this graph, and we're going to do the domain in inequality notation, it is tricky. Okay? It's going to look different than any one we've done so far. That's why I'm not telling you to pause the video and pick. Remember, domain is left x value to right x value. From your least x value to your largest x value, which is left x value to right x value, because x is run left to right. What is my, so let's just take a second, let's circle. What is my most left x value used to be happening? We're going to circle that in red. Boom. What is my most right x value you see happening? We're going to circle that in pink. Boom. Okay. What is the x value for this point? Negative 4. That's my most least x value. What is my largest x value? 4. Okay. So now, every other problem before now, we've either been all real numbers or we've just been growing after one number. So in other words, it's been like x is greater than 2, y, or x is greater than negative 1, y is greater than 2. Okay? So you notice that we just either grow after 1 or we just decrease after 1. This is the first problem where we actually have to show that we're bounced between 2. Okay? And this is much easier to do in interval notation than it is in inequality notation. But I'm going to show you how to do it in all of them. Okay? In inequality notation, you need to know your two numbers. Well, in all notations, you need to know your two numbers. But I'm between negative 4 and 4. So what you do is you first write down negative 4. Now, what are we doing after negative 4? We're getting bigger than it, right? So I could say that x is greater than or equal to negative 4. And the reason I say greater than or equal to is because it's coming from a closed circle. So this guy gets a greater than or equal to symbol. So x is greater than or equal to negative 4. But that's not all that happens, right? Because if I was just to write this, then I would not be including this. I would need an arrow here in order to just write this. X is greater than or equal to negative 4. My graph goes and stops right here in an x value of 4. So that means that my x values are always less than 4. Or let me redraw that less than sign. Less than 4. So that's actually what my domain is. X is greater than or equal to negative 4, but x is less than 4. And the reason I don't put an equal sign here is because it's coming from an open circle. Alright, so now let's talk about range. Okay? Well, range is the exact same thing we just did, but instead of for x values, we do it for y values. So let's circle our lowest y value right now. We'll do that in blue. Hopefully you're like, oh, well, my lowest y value is right here at 2. And my highest y value, we'll circle that in orange, is right here at 2. So that means my highest y value was 2, my lowest y value was negative 2. So once again, I'm trapped between two numbers. So the way I write that is y is greater than negative 2. Do y'all see how I'd be growing compared to negative 2? I'd be going up compared to negative 2. So y is greater than negative 2, but it doesn't get to continue going on forever. I need to demonstrate that it stops here at 2. So I say that it must be less than or equal to 2. And there you go. So then set notation, guys, is the exact same thing. You just simply draw your curly bracket and your straight line, and then you just write whatever you got for inequality notation. Okay? Set notation, the only new thing about set notation anytime is having to draw the curly bracket, put the variable, excuse me, and then write the inequality. There you go. So that's set notation. Okay? Interval notation. For this kind of problem, to me, interval notation makes the most sense. Because remember, interval notation is just simply your least number, comma, your greatest number. So then for domain, what was my least number? In other words, what was the smallest x value I had? Well, it was, sorry, I honestly forgot. The smallest x value I had was right here at negative 4. And the largest x value I had was right here at 4. So then, I just know that my least number was for x's was negative 4. And my greatest number was 4. And then all you have to do is say, okay, negative 4, was it an open circle or closed circle? It was closed. 4, was it open or closed? It was open, so it gets parentheses. You do the same thing with range. You just think about what is your least y value to your greatest y value. Well, my least y value was negative 2. My greatest y value was 2. And negative 2 came from an open circle, so it gets a parenthesis. And 2 came from a closed circle, so it gets a bracket. Alright? Alright guys, that is how you find range from graphs. Okay? Sorry this video ran a little bit long. I usually try to keep them shorter, but I really wanted to go into depth explaining how to find the domain and range. Okay, so if you have any homework to do, make sure you get it taken care of. Alright guys, see ya.